Hello students, and welcome to this lesson on the periodic table and periodic table trends. What I recommend doing while watching the video lesson is to watch this on a laptop or possibly do split screen, so that way you can still take notes on your iPad. I would also recommend, if I ask you to pause the video, try something out on your own, that you do that as well. So what I would like you to do now is take a second and pause the video and answer, what are some trends or patterns that you already know about the periodic table? So back in the 1860s, there was a scientist called Mendeleev. What he was doing is, keep in mind, in the 1860s, they didn't have a periodic table like we have now. In fact, at the time, they only knew about 63 of the current 118 elements. So with that, he was trying to create a textbook to use with his chemistry students. What he did is he organized what they knew about the elements similar to a deck of cards. So he knew elements' names, their mass, and some properties about them. And then he also knew their behavior and reactions with hydrogen and oxygen. So what he did is he started to organize them by similar properties going down, and then he organized them by their mass going across. So originally, Mendeleev arranged the elements into rows in order of atomic mass. Keep in mind that's different than what we know now, where it's arranged by atomic number, which is the number of protons. While these two are usually the same, I'll give you an example on the next slide where the atomic mass actually goes down even though the atomic number went up. So here's an example of what Mendeleev's periodic table looked like. He had all of these as having similar properties, so hydrogen, lithium, sodium, potassium, which we all know to still be true. But he also put copper in there, which is actually a little different now, but it still reacts similarly. Then going across, you notice he has this increasing by what they knew the atomic mass to be. Of course, now atomic masses are much more accurate than they were back in the 1860s. But what's fascinating with Mendeleev's periodic table is he had these empty spaces, similar to in a deck of cards. If I were to take out the 2 of hearts and the 5 of spades, you could probably figure out which cards were missing because of the patterns that are there. So he actually predicted 6 new elements while creating this periodic table. So again, Mendeleev predicted 6 undiscovered elements and their properties. And then in 1913, the periodic table was rearranged by Henry Moseley by increasing atomic number. One example of the differences between the arranging by atomic mass, which is what Mendeleev did, and arranging by atomic number, like Moseley did, is if you look at your periodic table, you will see that atomic number for cobalt goes from 27 to 28, so increasing by 1 proton. The atomic mass, however, goes down. So cobalt is 58.93, nickel is 58.69. So nickel's isotopes actually tend to be lighter than cobalt's, even though nickel has an extra proton. Basically what that means is cobalts tend to have a lot more neutrons than nickel does. But that's why we arrange the periodic table by atomic number now and not by atomic mass. I like to include this slide just to show you guys what a full-size periodic table looks like. So those elements that are down below, those 2 rows that are down below, what actually happens is you'll see that space on your desk or on a lot of periodic tables, that space that's like right around here. What really the periodic table should look like is those 2 rows that are usually down below are pulled up, and then the periodic table is kind of split and pushed over. So really this is what a periodic table should be arranged like. The reason that we take these 2 rows and pull them down is so it fits on a sheet of paper. So on your periodic table, you have what are called periods going across. So you have 7 periods on the periodic table. Those are your rows. And then you have 18 groups going across, and the groups are what run up and down. Then on your periodic table, it's pretty well broken apart into 3 different categories. You have your metals on the left side of this stair-step line. Keep in mind the one exception is hydrogen. Hydrogen's exception to a lot of things. But again, think of this in real sense, metals. So you'll have metals like copper and iron in this area. The lithium that's in your batteries, sodium that you eat is actually a metal. Calcium that you need to survive is a metal. So these are all metals. Then you have your non-metals off to the right side, and then don't forget about lonely little hydrogen over here. But non-metals, so things that are not metal, like your gases, like the oxygen that you breathe, nitrogen that makes up 80% of our atmosphere, your noble gases, so things that are not metals are on the right side of that stair-step line. Then you have your metalloids. They are things that have properties similar to both metals and non-metals. Some of those are like silicone, which are used in a lot of computer devices. The one exception here is aluminum. So for the most part, it's anything that touches this stair-step line. The main exception is aluminum. So picture like aluminum foil that you have in your house. That is a metal, not a metalloid. All right, now we'll actually get into the group names. So on the left side here, you have your alkali metals. And those alkali metals are like, if you've ever heard of an alkali battery, they are lithium-ion batteries. So they contain lithium. But your alkalis are that very first group starting lithium and lower. They are highly, highly, high reactive metals. They will actually react with just water. You can find some sweet YouTube videos about that. Then in group 2, you have your alkaline earth metals. Again, if you've heard of alkaline batteries, they will usually contain like magnesium. For groups 3 through 12, which is these groups right here, we have what are called our transition metals. Good way to remember that is they transition you from one side of the periodic table to the other. Group 13, you will notice, is element boron. Right here, well, those are just simply called the boron group. Then you have the carbon group, the nitrogen group, and the oxygen group. Those ones are pretty easy to remember because they just follow the name of the element at the top. One of the last groups is group 17. Those are your halogens. One way to remember that is if you've ever heard of halogen light bulbs, some of them will actually contain fluorine. Cool thing with halogens is they are some of the most reactive elements as well. Similar to your alkali metals, halogens are very, very reactive. Then over here you have your noble gases, which are helium, neon, argon, and so on. Your noble gases are very unreactive. Remember, they have that full outer shell of electrons, or that full outer energy level. They're content, they're not trying to gain or lose electrons, so they don't really react with anything else. The last two groups that we're going to learn about are the lanthanides, or lanthanide series, and the actinides, or the actinide series. These are actually referencing those rows on the bottom of your periodic table. One fantastic way to remember this is if you look at the first element right here, or depending on the periodic table, sometimes it'll be the element listed right here. That is actually called lanthanium, and so it's the lanthanide series. Similar with the actinides, either this element right here, or sometimes the one that's listed up here, is called actinium. Well, that's the actinide series. And now we're going to actually talk about periodic table trends going forward. Alright, so talking about some trends on the periodic table, please remember that the mass of an atom, also known as mass number, depends on the number of protons and the number of neutrons that an element contains. So the more protons and neutrons, well, the more mass that it has. The less protons and neutrons, the less mass that it has. So one thing to consider is when you look at the periodic table, you will notice that as you move from left to right, so as we go from like lithium over to beryllium, our average atomic mass increases. Lithium is 6.94, beryllium is 9.01. So as we move right across the periodic table, our atomic mass increases. And then you'll also notice as we go down, our atomic mass increases. So lithium is 6.94, sodium is 22.98, potassium is 39.09, rubidium is 85.47, and so therefore your average atomic mass also increases as you go down. Now granted, as you saw earlier with like cobalt to nickel, it's not a perfect pattern, but for the most part it holds true. One more is that your number of valence electrons, since that goes from 1, 2, 3, 4, 5, 6, 7, 8, that is increasing as you go left, working your way to the right. So this increases to the right. Your number of energy levels now is also going to increase as you work your way down. Because please remember, your number of energy levels is going to correspond to the period that that element is in. So hydrogen has 1 energy level. Lithium, beryllium have 2 energy levels. Sodium and magnesium have 3 energy levels. Potassium, calcium, and all these have 4 energy levels, and so on. And this last slide is meant to just be kind of a recap on all the different groups, which will make it easier for you to study. So again, you have your alkali metals, which are things like, your lithium batteries, are group 1. Group 2 are alkaline earth metals. Group 3, here you have the element boron. So this is called the boron group all the way down. Right here is going to be carbon. So therefore, these are all going to be the carbon group. You have nitrogen, which makes all of these the nitrogen group. And then you have oxygen, so that these are all the oxygen group. Then here you have your halogens and your noble gases, and then you have your lanthanide series and your actinide series. And that is it for this video lesson.